Hello everyone, how are you all? I hope you all are doing very well. You all are doing good. So, students, how is going on? So, we have started the chapter that is the is matter around us pure. Until now, what we have studied about it, we have studied about what are the elements and we have seen pure elements and not exactly pure element but yes exactly that type of the pure substances like elements. Today we are going to study about what the another type of it like the compounds we are going to study about, then we'll see that what are the type of the mixtures we are having. Okay, so before starting the session I would like to introduce myself. So my name is Arushi Sharma and I'm going to teach you this chapter. Okay, and the topics which we are going to cover in today's session is, so just give me a second, students. Actually my laptop is going to be dead. So I just have to connect it to the charging point. So it's done now. So now we can start our session. So these are the topic, students, which we are going to cover in today's session. That is the compound. Then we are going to see what are the properties of the compound. Then we'll see that mixture, that what is the mixture, and then we'll see the types of the mixture, homogeneous and heterogeneous. And then we'll see the difference between the mixture and the compound. Okay, so I hope now everyone is excited to see all these topics because they are very important for your chapter. Okay, and from your examination also. So, students, starting with the very first topic of today's session. So, it's about compounds. So, before starting compounds, like before explaining what is compounds, I just want to clear one thing. Like, do you know what are the pure substances? Exactly, because you have already studied that topic in the last session. And in the pure substances, students, if you have seen that there will be two classification. Two classification how? One we called it as elements and then one we call it as compounds. Exactly, and the another category is the mixtures. So we are going to see in this session only, but after some time. So elements and the compounds, and then elements are further divided into three categories. If we see here, so it's like metals, non-metals, and the metalloids. Okay, fine, students. But now, we have to study about compounds. But if you know that what are the elements, then only you can understand the compounds. So obviously, as you have seen, that elements are the simplest form which we cannot divide, which we cannot separate out any compound from them, that we call as the element. For example, like if we talk about iron sheet or copper sheet, so they will be having copper elements only. So if you are going to separate them out into another component, so it will be not possible for us. Why? Because it is having only one type of the element in it and we can't separate out it. Exactly. But now if we talk about compounds, so compounds are those type of substances, students, which are having the combination of two or more elements. So what we can say about compounds, so it is a combination of two or more elements. So when two or more elements combine together, then it formed as the compounds. Now you'll say, ma'am, when there is a mixture, when you can say that the combination is going on. So how we can say that it is a type of pure substance? Because student, like if I give you a very silly example, you'll say, ma'am, what you are saying, like water. Water, we know that it is the H2O molecule only. That H2O compound is there. Exactly, but if we see that H2O will be H2O only, it is not going to be altered at any position. Whenever you are going to check out the formula of the compound, or if you are going to see that what are the water particles are present, so it will be having the formula of only H2O. There will be no any other element added to it. That means it does not contain any other element. It will be having only hydrogen and oxygen. That is why we are considering as the pure substances. Fine, it's not only about H2O, even though we are having many other compounds as well. Like if I give you example, H2O, CO2, and calcium carbonate. Like as I have told you, it's not only like that two elements are combining together. There can be condition when two or more elements are combining and forming compounds. Now, what's the specialty about the compounds? Like why we are considering them as the pure substances? So we are considering them as the pure substances because, student, in this, what happened when elements are combining together? So they combined in a fixed ratio. So the combination which is going on, it is going on in the fixed ratio. That means, like if you see here that H2O H2O. So in the H2O, there will be two hydrogen atoms and one oxygen atom. That means if you notice here that to the one oxygen atom, two hydrogen atoms are attached, and that is how, student, it is a fixed ratio of H2O, that you can say is the 2 is to 1 or 1 is to 2 if you see hydrogen to oxygen or to oxygen to the hydrogen. So you will be finding out that the compounds are the combination of two or more elements which are combining together in a fixed ratio, and that ratio is not going to be altered at any condition. Okay, like if you see that water is there, okay, if you have, whenever, like if you trying to find out that what are the water molecules or what's the chemical formula of water, so if you ever notice that thing, not exactly by naked eyes, we can't do that exactly, so you will be not finding the water formula as H2ON, like N is going to be at H2OC. It's not possible because the compounds are always fixed in a like in a proper ratio, so that cannot be altered. So that's how, student, compounds are also considered as the pure substances, because their composition is not going to be changed at any condition and they will be fixed always. Fine. So that's how, student, this is the compounds. Now, if you see that what are the mixtures, because we are having mixture as well here. Now, what happened? From the word mixture only, we are getting that idea that mixture is something where the two or three components are combining together and then we are forming it as the mixture. But you will say, ma'am, compound is also a type of mixture. So why we are considering the mixture as not the pure substance? Why we are not concluding here, like including that mixture here? So the main reason behind mixture is that the mixture which contains the component, they are not in any fixed ratio. Okay, and it will be the possibility that you can separate them out easily. Fine, but if you see here for the compounds, is it possible, like water is flowing in front of your eyes, and is it possible to extract out hydrogen from it and oxygen from it by your hands only? Exactly, no. So by applying any physical force or by doing any physical you can say experiment, we cannot divide, like we cannot separate out the elements from the compounds. But yes, it is possible to do in the case of the mixture. So that's how, student, pure substances are only divided into two categories. One is the elements and another one is the compounds, because compounds are a combination of two or more elements where you will be see that those elements are fixed, like they are combined together in a fixed ratio and we can't separate them out physically. But it is a possibility to separate out the components physically in the case of the mixtures. So that's how mixtures are not considered as the pure substances and the compounds are considered as the pure substances. Okay, I hope everything is clear about compounds till now. Good. So now we are going to see the characteristics of compound. Like what are the characteristics of the compounds or what are the properties of compound? So the very first thing, student, if I'll say, so these are the pure substances. Pure substances, exactly, because they are having particular elements in their formula and those elements are always fixed in a proper ratio, in a proper, like there will be no any alteration in their ratio. So that's how we can consider them as the pure substances. Now, the very first point is elements are not easily separated by physical means. Like physical means, student, by doing any physical experiment or by doing any physical, applying any physical condition, we cannot separate out their elements. Which are present in the compounds. So that's how this is the main property of the compounds. Then, secondly, the compound has properties quite different from the element it is formed from. Obviously, student, it's not like that if elements are combining together and forming one compound. So it's not the must condition that the property of the elements are going to transfer to the properties of the compound as well. If I give you example here, that H2, H2 is a gas. We all know this thing. That is the hydrogen gas. O2 is again a gas. है ना? But when we combine this H2 and O2, so what we are getting? We are getting H2O. So don't go over their chemical properties. I'm not asking that you have to go in very deep. What you can do here, you can just check their physical state as well. Like the hydrogen and oxygen, they are present in the gaseous form, but when they are combining together, so they are forming H2O, and we know this thing that H2O is present in the what form? That is the liquid form. So obviously, student, as we have studied about the liquid and gaseous form in a very first chapter, that in which we have seen that the different properties of gas and liquid. So that's how, student, if you see that here the elements which are used up in the formation of the compound, they are having different properties, and the compound which is getting formed, it is having the different properties. Okay, Fine, students. Any doubt till now? So that's a very important point about the compounds, that it is not a very must condition, and it is not like that the properties of the elements are going to transfer to the compound as well. Okay. Now, the third point is the formula of a compound summarizes the whole number atomic ratio. Obviously, like the whole ratio we are getting from there. For example, if you see methane, like you'll say, ma'am, what's the methane is? So, methane, if I'll tell you that is CH4, these are the type of hydrocarbon compound. Hydrocarbon, the compounds which contain hydrogen and carbon, that we called as the hydrocompounds. And definitely you are going to see this chapter in your class 10th. You will be having whole chapter about carbon and its compound, so don't worry about that. Right now what you have to see the properties of compounds. Okay, so if you see here, student, that to the one carbon atom 4 hydrogen has been attached. So from this only we are getting the whole number, like we are getting the whole ratio, atomic ratio, that in what ratio elements are present in it. Fine. So by just looking at the chemical formula, we come to know that okay, in this particular chemical compound, that we can see that 2 hydrogen is attached to 1 oxygen, or the 4 hydrogen attached to 1 carbon. But now somehow students are getting confused that, ma'am, in H2O there are only 2 hydrogen attached to oxygen, but in the CH4 there are 4 oxygen attached to the carbon. So students, don't worry about it. It depends upon the valency, or we can say that the valence electron, or we can say that the like you it's not like that oxygen is very much favorable towards hydrogen, no. But it totally depends upon the number, like we can say that the number of valencies, or the number of valence electron present in outer shell of a particular atom. Okay, which will like the electronic configuration and everything, which we are going to study in our chapters. Okay, so don't get worry about it, that why two hydrogen is attaching with the oxygen, and here 4 hydrogen is attaching with carbon. Okay, so that's all the point. But from the formula only we come to know that okay, how many atoms are present in it and how the atoms are attached to each other. See, student, 1 carbon is there, so definitely 4 hydrogen is attached to that 1 carbon. So that's the chemical formula of it. Okay, the word formula can also apply to elements, like elements you can also, like the word formula we can also apply to the elements as well, like hydrogen, H2, like H and H combining together forming H2, O and O combining together forming O2. So that's how, student, they are also having the form, like we can also apply this word formula to the elements as well. Okay, so I hope till now each and every property of the compound has been like clear to you. So the very first property, that they all are present in a very fixed ratio which is not going to be altered. Secondly, we can't separate out the elements by using the physical means or by applying the physical conditions. Then third, we can see here that the compounds are having the different properties as compared to their elements, that it's not like that the elements which we are using to make the compound, so the properties of the elements are going to transfer to it. Okay, now students, one more thing here that you can see, that the if you talk, like if we talk about compounds, so they are having fixed melting point and boiling point. Fixed melting and boiling point. Why, students, like why they are having fixed melting and boiling point? We know this thing, that the H2O starts boiling at 100 degrees Celsius, and if we talk about its melting point, so that is 0 degrees Celsius. So because, students, it's not like that we cannot separate out their elements physically, so when they are present in the form of the compound, they show the fixed melting and boiling point. Fine, students. And when we can't separate out any elements by using any physical means, so that's how, student, we call them as the type of the homogeneous substances. Homogeneous substances. Now you'll say, ma'am, why we are calling them as homogeneous? So when you're going to see homogeneous mixture, your doubt is going to be clear. Okay, so don't worry about that. So right now, student, these are the properties of the compounds which we can see here. Pure substance. Secondly, fixed ratio. Can't separate them out by physical means. Properties are not same for elements and the compounds. We can find out their atomic ratio properly. Fixed melting and boiling point. Homogeneous substance. Like homogeneous, why, students? Because now we are going to see the mixture. So what are the mixture? So mixture, Like if we mixture is anything, when you are mixing 2, 3, 4, 5, 7, 8 many things together, so we get it in the form of the mixture only. For example, when we cook food in our house, like when our mother cooking food and when she's making vegetable, so she's having vegetable, then she's having many spices, salt and red chili, turmeric, and coriander. So many ingredients are there. Exactly, so many components are there. So when we mix all these components, then we are getting cooked vegetable and then we are eating it. Exactly. So that is the mixture, student. When we add many compounds together and then we call it as a mixture. So you will say, ma'am, the compounds are also a mixture. Yes, student, that is also a mixture. But what's the difference between the compound and the mixture? I have already told you that in the compound there is a fixed ratio, but in the mixture, student, there is no such fixed ratio. Like it is variable, it depends on our conditions. For example, like some people like very little salt in food, some people like more amount of salt in food, so it depends upon our condition that we can vary it. Fine, so that is called as the mixture. And the very important thing about the mixture is that mixtures can be separate them out physically as well as the chemically. Okay, so why you will say, ma'am, how physically? Because see, when we prepare tea and we have to that contains some tea leaves or something like that, and we have to separate them out, so we are using just that sieve we are having, okay, is that kind of whole kind of thing, so we can separate them out. Exactly. So that's how, student, we can separate them out, separate the mixture, and they are not present in the fixed ratio. That's why, student, we don't consider mixture as the pure substance. Okay, so because they are having different components. But now mixture has been divided into two categories. Now, what are those two categories? So the two categories are homogeneous and heterogeneous mixture. Now, students, if you remember one thing, homo means same, hetero means different. Homo means same, hetero means different. Now you'll say, ma'am, why you are telling this thing to us? Because, students, like homo, if we talk about homogeneous mixture, so you can see this first picture for the homogeneous. And this is the second picture for the heterogeneous mixture. Okay. So for the homogeneous mixture, students, what happened that okay, just starting with the example. In this example, students, you can see that it is a water in a glass, and in this glass of water, the person is adding a spoon of salt. Okay, that okay. When the salt is added into the water and when we are stirring it, so what happened after some time? So that salt is going to be soluble in the water, completely dissolved. Okay, so after that, what we observe that we just find out only one phase, like how we are just getting one phase, because after dissolving it, what after completely mixing that salt and water, so we are just getting water only. And when you taste it, you will be feeling that that water is salty in nature. So where does that salt goes? So as we have studied in our matter chapter, that the matters are made up of particles and they are having spacing between them, so that's how they get mixed up together. But now that, students, these type of mixture in which we are not able to separate them out physically and we are not able to see them separately with the eyes, so we call this such type of mixture as the homogeneous mixture. In that, we are not able to find out that what particularly we have mixed in it. Okay, like if I give you like, oh, sorry, one example, that we are having two glasses. In in both the glasses, we are having some amount of water. In one glass, I'm adding sugar, and in one glass, I'm adding salt. So I have just mixed it. But now I'm asking you that which one is having salt and which one is containing sugar. So you will be getting confused that, ma'am, how I can tell it by just looking at the picture, because both are looking at the same only. But when you taste it, so one will feel as the sweet and one will feel as the salty. So that's how you can getting the idea that, okay, this glass is containing sugar and this that the another one is having salt. But, student, if just looking at the picture you are not finding out clear idea that what you have mixed into it, or we can say that the component has been mixed up with the other component in such a way that they are having the same structure throughout, same phase throughout, so such type of compound, or such type of mixtures are called as the homogeneous mixture. Okay, so you will be having same phase throughout the mixture, same phase, or we can say that the one phase only. Fine, students, so such type of mixtures are called as the homogeneous mixture. Now coming to the heterogeneous mixture, so obviously, student, now we are very smart. Exactly, we know when we are studying homogeneous and heterogeneous, so obviously hetero is going to be vice versa of homogeneous. Exactly. So now from that we can have some idea that homogeneous mixtures are those mixture which are having same phase, and you can see that the particles are arranged in the uniform manner. So that's how you will be getting uniformity here. But if we talk about heterogeneous mixture, so in heterogeneous mixture, students, what happened when you are mixing something? So you will be not getting only one phase. For example, you can see here that this is a blue color, like blue color component, which we are adding in the water, and it is not soluble in the water. It is just getting settling at the bottom of that glass, and you will be finding that the two phases are there. One is water, and one is that blue component, because that blue component is not soluble in water. So when students, we are having such type of mixture that after mixing the components, we are having the two phase or the different phase, or we are having some particles in it, and we can see some kind of layer between these two components. So such type of mixtures are called as the heterogeneous mixture. That means different phase. Okay, and as well as you will not finding out any uniformity there, non-uniform. Fine, students. For example, like if you have noticed one thing, it's not like that always they are just getting settling at the bottom, like chalk and water. So chalk made a kind of suspension that some of the particles are getting dissolved in the water, but some of the particles are settling at the bottom only. So students, at that point also there is no such a, we can find out two phases, na? Like the chalk is separated and water is separated. So when we are having these two different phases in one mixture only, that type of mixtures are called as the heterogeneous mixture. That means particularly looking at that mixture, we will be able to find out that what we have mixed in it. Like chalk we have mixed, so we can find out that yes, some white particles we have mixed in it, blue particles we have mixed in it. So that's how student mixtures are something when we mix two or three components together, and they are not fixed in the ratio, they are variable in nature. So that we called as the mixture. And sometimes mixture can be homogeneous and heterogeneous, so both are the condition, but compounds are always homogeneous, because students, like now you know this thing that homogeneous are something which are uniform throughout. So the compounds are always uniform throughout. If it is H2O, so it will be H2O only. Fine. So the homogeneous mixtures are those type of mixture in which you will be not finding out any layer between the components, any other, like you will be not finding out any different phase, there will be only one phase only. And in the heterogeneous, that's the whole, like complete vice versa of it. Like you will be finding out that what are the particles are there, what type of particles you have added, they are not properly soluble in it, different phase, you will be finding out some layer as well. Okay, so such type of heterogeneous mixture we generally find it out in the case of immiscible liquids. Immiscible liquid, students, the liquids which are not mixing up together, or those are not having the property to mix together, for example oil and water. So in that condition we are getting heterogeneous mixture. Okay, now coming to the difference between mixture and the compound, that what is the difference between the mixture and compound. So starting from the points here, that the compound composition of elements present in a compound is fixed, that it is completely fixed, it is not going to be altered at any condition. But in the mixture, the composition of the elements or the composition of the components is not fixed. Exactly, because in the mixture, like salt is there or sugar is there, so it depends upon us. It's not like that we can just add only one spoon of salt in water, and it depends upon the condition that we can vary that those amount. So in compound, the elements are fixed in a proper ratio, in a like in a definite ratio, but in mixture there is no such condition. The properties of a compound are different from those of its elements. Obviously, as we have discussed, hydrogen gas and oxygen gas combining together forming water molecule and having different properties. But in the mixture, student, it shows the property of all its constituents element. Definitely, if you see sugar, when you add sugar into water, so that water tastes sweet. Why? Because the property of the sugar has been transferred to that mixture. So that's how there will be some transferring of the properties in the case of mixture. Fine. Its constituents can be separated by chemical method only. Like if we want to separate out hydrogen and oxygen from the H2O, so we have to do some chemical process so that we can separate them out. Like for CO2 as well. But if we have to separate out the mixture constituents, so we can either apply the chemical method as well, and we can apply the physical method as well. Okay, like sugar and water. Sugar and water, how can we separate them out? Either we can stain them, or like evaporation method we can do. So that's how student, in mixture we can apply for like as both the method, physical as well as the chemical method. Fine. Compound is always homogeneous in nature, as we have already discussed, because that is same throughout the condition. But for the mixture, it can be homogeneous or the heterogeneous. Both are the conditions. Okay, fine. And one more thing here, that they are having fixed melting point and boiling point. That's the important point. Melting point and boiling point. As we have already seen for water molecule, that is the 100 degrees Celsius or 0 degrees Celsius. But for the mixture, it is variable. It's not like that it is having the fixed melting point or boiling point. Okay, so with that, student, we have completed all of the topics of today's session. We have seen what are the compounds, properties of compounds, difference between homogeneous and heterogeneous, difference between mixture and compound. So with that, student, we have completed today's session. Now it's your duty to watch the session carefully, and if you're having any doubt, any question, you can put your question on public or private forum of Ask IITians, and you will be getting answer from expert side. Okay, students. So till then, study well, and thank you very much for watching the session. Keep learning from Ask IITians. Thank you.